Good morning everybody. Remaining functions we will discuss now on today. First is, yesterday we discussed up even and odd function. Now we will discuss identity function. Identity function. What is an identity function? What is an identity function? Identity function means mapping to itself. Mapping to itself is nothing but if f is a mapping from A to A, if f is a mapping from A to A, f is a mapping from A to A, such that f of x equal to x, f of x equal to x for every x belongs to A, for every x belongs to A, f of x equal to x, then f is said to be an identity. Then f is said to be an identity function. Said to be an identity function. F is said to be an identity function. If f of x equal to x, then f is said to be an identity function. If we draw the graph of the identity function y is equal to x, is an identity function. So y is equal to x, line will be like this. So this is an identity function. Best example of identity function is y equal to x. So this is the graph of the identity function y equal to x. Now identity function is always the graph of the straight line which is equally inclined to both the axes. Which is equally inclined to both the axes. This is y equal to x. So always identity function will be y equal to x. So this will be like this. Next, example if I take A is equal to 1, 2, 3. Then an identity function always represented with IA. Identity function from A to A is represented with IA. Like identity function from B to B is represented with IB like this. Identity function from A to A is IA. Identity function from B to B is IB. So identity function is represented with IA I told. So IA is always equal to 1, 2, 2, 3 like this. So if A is 1, 2, 3, identity from A to A is 1, 1, 2, 2, 2, 3, means y is always equal to x. Then it is called as an identity function. Next is constant function. Next one is constant function. Constant function. What is meant by a constant function? F is a mapping from A to R or A to B, where A, B are subsets of real sets or particular real numbers. If F is a mapping from A to B, is a function such that f is a mapping from A to B is a function such that f of x equal to some k. F of x equal to some k means all the elements of A are mapped to only one element in B, where k belongs to B. Means all the elements of A are mapped to only one element in B. Then it is called as a constant function. For example, A is 1, 2, 3 and B is 1, 2, 3. But R are mapped to only 2 or R are mapped to only 3. Then it is called as a constant function. Right. For every x belongs to A, where k belongs to B, for every x belongs to A, f of x equal to k. For every x belongs to A, f of x equal to k, then it is called as a constant function. And if A is containing, for example, A is containing some 3 elements, B is containing 3 elements, but all the elements are mapped to B only, or 2 only, or all the elements are mapped to 3 only, means all are mapped to one constant fixed element, then it is called as a constant function. So for every x belongs to A, f of x equal to k. for every x belongs to a, f of x equal to k, then f is said to be a constant function. Then f is said to be a constant function. Means the range of a constant function, the range of a constant function is always singleton set. Is always singleton set. This it always be mapped to only one element. So range is always equal to, range of constant function is always equal to singleton set. So range of a constant function is always a singleton set. Means always mapped to only one element. Means simply if you draw the graphically, it is always a horizontal line. Or y equal to some k, mapped to k, means y equal to k is the graph of the singleton set, graph of the constant function. Y equal to k is the graph of the constant function, is the graph of the constant function. And constant function is periodic with no period, is periodic but no period, is not having fixed period. So it is, can be y equal to k like this, can be y equal to k like this, can be y equal to k like this. Depends on which value we are mapping. If we are mapping to 1, this is this. If we are mapping to 2, this is this. Like if we are mapping to -1, this is this. Like this. So all of A will be mapped to only one element in B. Then f is said to be a constant function. Then f is said to be a constant function. Then f is said to be a constant function. Next one is composite function. Composite function. What is a composite function? If f is a mapping from A to B is one function, and g is a mapping from B to C is another function. F is a mapping from A to B is one function, and g is a mapping from B to C is another function. Means f is a mapping from A to B and g is mapping from B to C are two functions. Then G circle F is a mapping from A to C. G circle F is a mapping from A to C such that G circle F of x equal to G of f of x. G circle F of x equal to G of f of x. Such that G circle f of x equal to G of f of x for every x belongs to A. Then G circle f is said to be a composite function. Then G circle f is said to be a composite function. Means f is a mapping from A to B like this. This is f. And G is a mapping from B to C like this. Then G circle f is a mapping from A to C like this. F is a mapping from A to B. G is a mapping from B to C. Then G circle f is a mapping from A to C. Means G of f of x. G circle f means G of f of x. G circle f means G of f of x. Is called as a composite function. Now we will discuss how to find the domain and range of all these different functions in exercise 1C. Exercise 1C. Exercise 1C. First problem. Find the domains of the following real valued functions. Find the domains of the following real valued functions. Find the domains of the following real valued functions. First function, f of x equal to 1 by x square minus 1 into x plus 3 into x plus 3. X square minus 1 into x plus 3. We already discussed what is meant by real valued function. What is a real function? Real valued function means codomain range equal to real, and domain and codomain both are real numbers is called as real function. Now find the real value domain of the real valued function. Means what is the domain of this function in the real numbers? What is the domain? Domain means for which value of x the function is defined. First of all, what is domain we discussed? Domain is f is mapping from A to B. A is called as domain, B is called as codomain, and which have been mapped are called as range. We already discussed. Means for what values of x it is mapped? When it is mapped? If f of x is defined for that particular value, then only we can map. If denominator 0 undefined, where can I map for x equal to 1? If x equal to 1, for example, in the domain 1 is there, 2 is there, 3 is there, I can map 2 to some value for which f of 2 value is. And how can I map f of 1? Because f of 1 is infinity. Where can I map? Undefined. I can't map. So all the values of x for which the function is defined, all the values of x for which the function is defined is called as the domain. All the values of x for which the function is defined is called as a domain. Now he is asking domains. Means where the function is defined. When do the function is defined? Function is defined for all values of x except the denominator is 0. If the denominator is 0, then this function is not defined. So it depends on the function it is. Here denominator it is having. Means the function is defined only if denominator is not 0. Means domain is x square minus 1 not equal to 0, comma x plus 3 not equal to 0. Function is defined only these two are not equal to 0. Means x square minus 1 not equal to 0, x plus 3 not equal to 0. Implies this I can write as x plus 1 into x minus 1 not equal to 0, and this I can write x not equal to minus 3. Means for x not equal to minus 1 comma 1 and x not equal to minus 3. So function is defined excluding these three values not equal to minus 1, 1, minus 3. So excluding these three values, for all the remaining values function is defined. So domain equal to, therefore domain D equal to, general representation D, domain equal to all real numbers excluding these three. So r minus 1 comma minus 3 comma 1. So excluding these three values, for any real number function is defined. Therefore domain equal to any real number excluding these three. Means r real number set is represented with capital R, you know. So capital R minus these three numbers. So excluding these three, any real number function is defined. Therefore domain is r minus of minus 3 minus 1 1 is the domain of this function. Like this we will discuss all the domains and range. Definitely you will get 1 2 marker from this, 1 2 marker 100% from this exercise. Like the same second sum, f of x equal to 2x square minus 5x plus 7 minus 5x plus 7 divided by x minus 1 into x minus 2 into x minus 3, x minus 1 into x minus 2 into x minus 3. F of x equal to 2x square minus 5x plus 7 by x minus 1 into x minus 2 into x minus 3. So where this function is not defined. If the denominator 0, function is not defined. Means x should not be equal to 1, 2, 3. Remaining values function is defined. So domain is nothing but x minus 1 not equal to 0, x minus 2 not equal to 0, and x minus 3 not equal to 0. Implies x is not equal to 1, x is not equal to 2, x is not equal to 2. Implies domain equal to any real number excluding these three numbers 1, 2, 3. Any real number excluding these three elements 1, 2, 3. Excluding 1, 2, 3 for all the remaining elements function is defined. Therefore domain equal to r minus of 1, 2, 3. We can decide like this. Next, f of x equal to 1 by log of 2 minus x. 1 by log of 2 minus x. When this function is defined? This function is defined the same concept, denominator should not be equal to 0. So first of all, log of 2 minus x not equal to 0 because this is in denominator. So log of 2 minus x not equal to 0 is nothing but 2 minus x is not equal to e power 0, 1. So x not equal to 2 minus 1, 1. X not equal to 1. So function is defined for all real values x is not equal to 1 in general. But here you should take care about log. Log is not defined for any value. Log is defined only for positive values. Log is defined only for positive values. Means here one more thing is this 2 minus x should be greater than 0 because log is defined only for positive values I am saying. So positive value means 2 minus x is more than 0. Log 0 also undefined. So there is no equal to also take care. So 2 minus x must be greater than 0. Is nothing but minus x is greater than minus 2. Implies x is less than 2. X is less than 2. So now coming to the domain. Domain is x less than 2 but not equal to 1. So if you have not go for the number line, this is 0, this is 1, this is 2, this is 3 like this, minus 1 and so on. Now less than 2 is all the values but excluding 1. So minus infinity to 2 but excluding 1. So how can I write? Domain equal to, therefore domain equal to minus infinity to 0, minus infinity to 2, excluding 2, excluding 1. How can I exclude these? Two things keep in mind. I am excluding 1. So how can I exclude? Two ways. Minus infinity to 1. If I am keeping open bracket, I am excluding 1. Union 1, 2. Union 1, 2. This is one way. Or another way. Minus infinity to 2. Excluding means open bracket always. Minus 1. So two ways of representing. Your choice of representing. But here most important thing is that function is not defined x equal to 1 and not defined for any value more than 2 or equal to 2. So only up to less than 2. So minus infinity to 2 excluding 1. This is most important. Representation is most important here. This is called as open bracket. This is called as open bracket. Open bracket means excluding that value. This is the upper boundary but not equal to. This is the upper boundary but not equal to 1. Like if I am keeping open bracket on this side, this is the lower boundary. 1 is the lower boundary but not including 1. But not including 1. This is deleted neighborhood of 1 but not 1. Deleted neighborhood of 1 but not 1. Like the same, this is neighborhood of left neighborhood of 2. This is left neighborhood of 2. This is right neighborhood of 1. So excluding those two values, we are taking remaining values. So like this we will define the domain. We will define the domain. And this minus usually represented like this. Instead of minus representation excluding one is backslash. So your choice of either this or this. Both are one and same type one more sum. Find the domain of 1 by root of 1 minus x square. Here also you should take two things. Should take care of two things. One is denominator should not be 0. First thing. Second thing, root is defined only for positive values like your logarithm. Root of negative values is called as complex number, not real number. We need real valued function. So we need real valued function. Therefore, root of this should be greater than 0. So there are two things to be considered. One is denominator not equal to 0, means 1 minus x square not equal to 0. And the second thing is root is defined only for positive values, means 1 minus x square greater than or equal to 0. 1 minus x square greater than or equal to 0, but not negative. By combining these two, if you observe, this is not equal to 0, this is greater than or equal to 0. If I take greater than 0, both can be mixed together. So instead of writing two things, I will write at a time 1 minus x square greater than 0. 1 minus x square greater than 0 is nothing but not equal to 0 as well as greater than or equal to 0. So automatically it is only simply greater than 0. If I take minus common, inequality will change. Means x square minus 1 less than 0. X square minus 1 less than 0 is nothing but mod x less than 1. Implies x lies between plus 1 to minus 1. X belongs to plus 1 to minus 1. Means minus 1 to 1, but not including. There is no equal to, means not including. Same open bracket. So this is right neighborhood of minus 1, but not left side. Left side is not considering. This is the lower boundary, this is the upper boundary, but all the values between this. Lower boundary is minus 1, upper boundary is plus 1. All the values infect in the two, but not those two. But not minus 1 plus 1. Remaining all values will come. So we can represent like this. So minus 1 to plus 1. So like this, we will find the domain of the any function. So by considering all the things, one is function is when do the function is defined first thing. When do the function is defined. This function is defined only for positive values. Root is defined. But denominator is there. Denominator is defined if denominator not equal to 0. P by Q form is defined only Q not equal to 0. That's why Q not equal to 0. So combining two, I am getting like this. 1 minus x square minus 1 greater than 0. 1 minus x square greater than 0. If I take minus common, inequality will change. So x square minus 1 less than 0 is nothing but mod x less than 1. X square, if I take off root, it becomes mod x. Mod x less than 1. This x lies between minus 1 to plus 1. Minus 1 to plus 1. Now one more function f of x equal to root of x square minus 1. If you take this function, if you observe, there is no 1 by. But what about this root value? Root is defined only for positive values. Root is defined only for positive values. Root is defined for 0 also. Defined for 0 also, but not for negative values. Means x minus 25 must be greater than or equal to 0. Must be greater than or equal to 0 to become this real number. Is as to real value function. So to become this f of x is a real number, x square minus 25 must be greater than or equal to 0. X square minus 25, 25 I can write as 5 square, means I can write as x plus 5 into x minus 5. Or mod x is greater than 25 I can write. Greater than or equal to 0. Implies x should not lie between, greater means x should not lie between minus 5 to plus 5. X should not lie between minus 5 to plus 5. Implies x should not lie between minus 5 to plus 5. Implies x belongs to minus infinity to minus 5. Here bracket important, closed bracket. Why closed bracket? It can be 5. Equal to is there. equal to means 5 including 5 is this union 5 to infinity including plus 5 including minus 5. So including is closed bracket. This is called as closed bracket. And previous bracket this is called as open bracket. Open bracket means excluding. Closed bracket means including that value. So here the upper boundary is infinity. Here the upper boundary is minus 5 in this part. So up to minus 5 and including minus 5. But not after right hand side of minus 5 is excluded. Here left hand side of plus 5 is excluded. But 5 is included. Like this. This difference, this is called as square bracket is called as closed bracket. The square bracket is called as closed bracket. This includes. And open bracket is called as exclude. Open bracket. This is called as open bracket. That is called as excluding that particular value. Here including that particular value also. There is a difference between open bracket and closed bracket. Same type exam. F of x equal to root of x minus step x. So when do x minus step x is defined? The root of x minus step x is defined only if this is positive. Means x minus step x is greater than or equal to 0. Root is defined only for positive. Where do this is defined? X minus step x always greater than or equal to 0 only. X minus step x is fractional part of x is always greater than or equal to 0 only. For example, we are taking x equal to 2.5. What is x minus step x? X minus step x. X is equal to 2.5 minus step x equal to step of 2.5. Step of 2.5 is 2. So 0.5 greater than or equal to 0 or not? Like if I take this minus 2.5, what happens? This is step of minus 2.5 is minus 3. Step of minus 2.5 is minus 3. Automatically becomes 3 minus 2.5. This is also 0.5. So what I want to say is, we know that x minus step x is always greater than or equal to 0 is called as fractional part of x. So this is always greater than or equal to 0. Implies what I want to say is, here the domain is x belongs to R. Any real number. For any real number this is greater than or equal to 0. So domain is R. Any real number. If the same sum is given in reverse order like this, x minus step x instead of step x minus step x. If it is step x minus x, now the problem comes to it. Step x minus x is given like this. Then when do this greater than or equal to 0? I told just now only x minus step x is always greater than or equal to 0. But x minus step x is always greater than or equal to 0 means step x minus x is always less than 0. So when do this is possible? This is not at all possible only except only for one thing. It can be 0. When do this is 0? Only for integers. If x is equal to some 2, step x is 2, x is also 2. Like 2 minus 2, 0. So equal to 0 is there. For remaining values of x minus step x is step greater than 0 means step x minus x is less than 0. But I need greater than 0. So only possibility is x belongs to integer. That is check. It is negative integer or positive integer. Step x minus x equal to, for all x minus step x minus step x is always greater than 0. But if for integers it is 0. So defined for only for 0. Remaining values is not defined because it is less than 0. Step x minus x is less than 0 always if x is not an integer. So only possibility is x is integer. X is integer, then it can be defined because it can be 0. So what can I say is simply domain is equal to integer set. But range of this function step x minus x is always 0. because this is defined only for integers. For any integer, step x minus x is 0. So range is 0, domain is R. Domain is R. Domain is R. Sorry, domain is Z, integers. Integers. Domain is an integer, but range is 0. Like this. We can do. Remaining sums we will do in the next class. Remaining sums we can do in the next class.